Good afternoon. My name is John Herzig. I'm the Deputy Assistant Secretary for Nuclear Technology R&D. The integrated research project that I'm going to discuss this afternoon is still in the formula stages. We're still putting all the pieces together, but we will have something out about the December timeframe. Specifically, this IRP is going to be in support of the design of a new sodium-cooled fast test reactor, which we call the versatile test reactor. Specifically, we want to get the university community some insight as to what we're thinking about in the R&D program so that you have time to think about it between now and when the call comes out. I'll give you an overview of some of the areas we're thinking about for the university program. Specifically, we're thinking of work in the area of safety analysis, core physics, reactor control design, and system safety. It is possible we may include some areas of structural analysis and seismic isolation. Those have not been decided on yet. In this particular IRP, we will expect the team, which will be an integrated team, to be integrated with Argonne National Laboratory, Idaho National Laboratory, Oak Ridge, and Los Alamos. And will most likely require travel to these sites at some points in time and possibly summer internships. NQA1 will be required for all analysis submitted as their final. Additional areas of consideration for this IRP will include pump design, coolant and loops that would be inserted into the reactor, inserted into the test reactor for other technologies such as molten salts, gas, and other sodium coolants. The IRP will be relying specifically on the expertise of universities which specialize in various areas. So basically what we're looking for is a hub and spoke model. That is, there will be an integrating university, which will be the hub, and specialties within all of the other areas. Those will be selected as part of the IRP and judged upon as we go forward. We are also considering a NIA proposal in the area of advanced instrumentation, which will focus on real-time data collection for experiments, for example, fuel conductivity. We are entering into a new era of big data, and we would like the experiments that we do in the test reactor when it comes up in operation, which will hopefully be between 2026 and 2029. At that time, we should have advanced instrumentation available to take all the data on the experiments and analyze them for our code validations. I look forward to this opportunity, and I welcome any questions.
We'll take questions in the GoToWebinar question box, so please submit them in writing there. John, we have one question. Should the IRP team be integrated with all the labs, INL, ANL, ORNL, and LANL, or only one or more?
Well, the main team or integrator will be INL, and they will make decisions as to what work would go to the various laboratories depending upon those areas of specialization that they're working on.
And how many IRP topics are there?
IRP topics? Well, we haven't decided on the full complement, but the areas we will cover, fairly certain we'll cover, are safety analysis, core physics, and reactor control and design and safety systems. That will definitely be within the call. Here we might add structural analysis and seismic isolation.
Will LEU fuel development efforts be considered?
The reactor will initially start up on LEU fuel, uranium-235, but we'll use fuel that contains plutonium, which may be required to bring the flux level up to the level that we're interested in, which is somewhere in the range of 3 to 4 times 10 to the 15th.
We'll stay on the line for a minute or two longer if there are any other questions. Will the concept be similar to the one proposed by ANL and INL, or can it be different?
The concepts will be laid out through an integrated team with INL being the lead, and those concepts will be selected by the laboratory team, and those will be the concepts for which the work will be performed against.
And how many IRP projects are expected to be funded through this opportunity?
At this point in time, we're thinking of one IRP, and we'd like to find out how it goes. If it goes well, we'll ask for more in the future.
Do you know when the description of the work scope will be posted? And will it won't require an LOI or pre-proposals because it's an IRP.
The description will probably be posted in December timeframe, probably early December. If it's possible to get it out earlier, and we'll talk with Mike Worley and others, we'll try to do that.
Will international collaborations be encouraged?
At this point in time, no.
Could you describe the RC-4.3 topic area? This is the development of an advanced instrumentation which permits the collection of real-time data.
Oh,
is that?
Yes. We're looking for expertise in sensors that can be put into fuel and collect real-time data. This is extreme environment, sensors that can hold up as a function of time during the experiment. The experiments are not going to be years, they're going to be 3 weeks to 3 months to maybe 6 months at the very most. But we're looking for the development of advanced sensors that can stay up within that environment of a high neutron flux, high temperature, and transmit that in real time out to a data collection system.
Okay, back to the IRP topic. Does safety analysis include shielding structures, or is it only for the core?
It will include shielding as well.
The new title of the IRP has similar, looks like a similar request to RC-4.3. Does this affect the viability of RC-4.3 being funded?
No decision has been made at this time.